We are recording, I believe. Yes, we are recording. Okay. Good morning. How are we doing today? Good. Yeah, I agree. Okay. So, yesterday, we talked about 2 to the x equals 2 to the 3x plus 1. We talked about something that looked like that, right? And we could solve that. We could solve that equation. What does it mean to solve it? Figure out what x is, exactly. That's what it means to come up with a solution. All right? What property or what characteristic of this equation allows me to do that? Let me rephrase that question. If I could change one thing to make this infinitely harder for you to figure out, what would it be? Changing the equal sign? I still want it to be an equation. I still want it to be an equation, so I'm going to keep the equal sign, but we can change just about anything else. What would I have to change in order to make this infinitely harder? There are two possible solutions. Zach, give me one. The base, which one? Or both of them? Either one? How about both of them? So if I change this and this, let's say I make them 3. Is that harder? No, I want different bases, right? Why does it go to that? I want calligraphy pen. So let's change this back to 2. Now I got different bases. This is much harder to figure out than yesterday's problems were. Because now I've added another layer of difficulty onto this. So the question is, how do we solve it? Well, we need the help of a function. Okay? They're going to call it the what power function. I'm going to give it another name at the end of the lesson. Okay? But for right now, it's going to be called the what power function. Is everybody with me so far? The what power function. Exactly. So, I ask you, what power of 2 gets me 8? 3, right? There we go. You see that? It's asking me, what power of 2 gets me 8? What power of 3 gets me 9? 2, right? Okay, now I'll do one that's the answer is not given. What power of 6 gets me 36? 2, right? Because 6 squared equals 36. So the answer is 2. Okay? What power of 2 gets me 32? We answered this question yesterday. It's 5, right? Nick, you got it. What power of 2 gets me 32? The answer is 5. What power of 10 gets me 1,000? 3. Good. Now, let's see if we can do the rest of these on our own. Actually, let's go down to x. No, actually go to ix. I want to go to ix because at x they start getting funky. And the funkiness is why I got this stuff written down still. Where my eraser go? There it is. So did you look up the friction pens?
Yes.
Did you look up the friction pens? How much they cost on Amazon?
They're kind of cheap. They're like $1 a piece, but like tax like 20.
Yeah. Just make sure you get the ballpoint and not the marker things. I should bring the marker thing. I bought them, and there were the marker ones, which don't work well for me. If you want them, I can bring them. And then you can erase. Yeah. How cool is that, huh? All right. Are we doing Roman numeral 6 through Roman numeral 9? Oh, 100. 100. I believe so. Because 100 to the first power is 100, right? 100 squared is... Yeah, you gotta be careful on that, right? All right, who came up with a solution for Roman numeral 6? Somebody other than Zach. Zach's been way too helpful. We gotta spread the burden. 6. Let's see. 1, 2, 3, 4, 5, 6. Yep, 6. Okay. How about Roman numeral 7? 3? But look at all the zeros here. Oh, you mean this guy?
Oh, yeah.
Yeah, it's 100. It's 100 to what power? So 100 to the first power is what? 100 to the first power? It's just 100, right? Whoa. Anything to the first power is just that anything, right? 100 squared, well, that's 100 with 2 more zeros after it. So that's 10,000. And then to the third power has got 2 more zeros after it, so it'd be like 1,000,000, right? Yeah, so third power. Third power. 4 to what power gets me 64?
3.
The third power. You notice how I changed my wording here? Instead of saying what power of 4 gets me 64, I said 4 to what power gets me 64.
Same thing.
So it's the same thing, I'm just switching it around. But this is going to help you. Okay? We're going to call this the log roll because I'm rolling. Okay? I do this. This is going to help you keep straight what it is we're doing. It is 2 to what power gets me 64? Right? 6. 9. Now, that's Roman numeral 9. Roman numeral 10, 9 to what power gets me 3? 9 to what power gets me 3? It's not a third. Who gave you that? Brandon gave me half. Nice. Because half, something to the half power is the same thing as saying the square root of something, right? So, so 9 to the 1/2 power gets me 3. 5 to what power gets me the square root of 5? 1/2. Same question, right, Jesse? Same question. Okay.
The next one be 1/4?
No. I like where you're thinking, but not quite. 1/2 to what power gets me 1/8? 3, right? Because 1/2 times 1/2 gets me what? 1/4 times 1/2 again gets me 1/8. So this is 3. Good. Okay. Do the log roll again. 42 to what power gets me 1? 0. 0. 0. Very good. like where we're going. Okay, 100 to what power gets me 0.01?
Yeah.
Math.
Is it a negative number?
Negative what, though? Let's go back over here. Let's go back over here. Which rule of exponents am I using over here? 1, 2, 3, 4, 5, 6, or 7? 4. 4. Think about this. Can I write 0.01 as a fraction?
But the number she was
Well, let's write 0.01 as a fraction. I want to rewrite 0.01 as a fraction. Who can do that for me? Go ahead, Nick. 1/100th, exactly. So this one is saying what power of 100 is 1/100. Now, let's refer to Rule 4 for some guidance in how to answer this. If I replace x with 100, what would be the power to get me that? 100 is, that's 100 to what power in the denominator? Just the first power, right? That's the first power right there, right? So what power do I take 100 to get 1/100 to the first power? -1. -1, exactly. That's how I get a number smaller than the original number. Okay? Now, that's how I get a number smaller than 1. Now, to what power do I take 2 to get me 1/4? Remember, 1/2 is square root. -2. -2, I have to flip it. That's what the negative does. And then I have to square it. So this is -2. Very good. All right, next page. 1/4 to what power gets me 2? This is a funky one, right? First, I got a fraction in the base, right?
Yes.
I got to flip it, which means my answer is going to be positive or negative. It's going to be negative, right? Now, 4 to the -1 power is, I'm sorry, 1/4 to the -1 power is 4, right? So what do I still have to do to this? I still have to take the square root of it, right? So then it's going to be negative what? 1/2. 1/2. Okay. We are going to jump down to, I want to do this one right here. Number 2 in exercise 2. What's that? I'm confused. Did somebody just tell me to go home? No? That's what it sounded like. All right. So let me ask you this. To what power do I raise 0 to get me 7? What do you mean there isn't one? I just asked the question. There's got to be an answer. You sound very confident about that. 0 to some power's got to equal 7, right? I'm asking the question. No, right? Thank you. So there is no solution to this one, right? How about this one? Okay, this isn't 0. I'm going to do number 4 now. 1 to what power equals 5? 1 to the 5th power. So 1 times 1 times 1 times 1 times 1.
Any power will always equal 1.
Ah, so is there a solution for this guy? No solution. All right. Now, funky number. -2 to what power gives me 16? Think about this one. -2 to what power gets me 16? 2 times 2 is what? I'm sorry, -2 times -2 is what? +4, right? Times -2 is -8 times -2 gets me +16, right? So my answer is 4. That equals 4. Let's try number 6 now. Let's use the same strategy here, shall we? -2 to the first power is -2. To the second power, Ethan?
4.
4. Good, good. To the third power, Jesse. -8. Good. To the fourth power, Trey. To the fourth power. We're at -8 times -2. +16. Very good. To the fifth power. -32, right? Negative. Is there a solution to this? No. No solution. No real solution. In other words, there might be an imaginary solution to this, but you won't get there this year. That's just a plug for pre-calc right there. That's a pre-calc plug. All right? I want to jump. I want to jump. Now, I replaced the term what power with the word logarithm. Logarithm. Who's seen the word logarithm before? All my juniors should be raising their hands, so should my seniors. Why do I say that? What's that, Caleb? We saw it on the ACT, right? And I feel very bad that I'm doing this lesson now as opposed to before the ACT. However, comma, I have said my piece. I've gone to confession. Now I ask you, where does the term logarithm come from? Comes from Greek. Comes from Greek. So, the log comes from the word logos, which is Greek for meaning speech, thought, or reason. Okay? The word logic comes from logos. The word dialogue meaning to have a conversation, comes from logos. Okay? I'm sorry? Dialect, it might be. I'm not sure how logos conjugates.
Like a tree log.
Different log. I like what you're thinking, though. All right, the other part of logarithm comes from the Greek word arithmes, which means number. That kind of makes sense because we kind of had to reason this idea out in our heads, right? It's not a complicated concept once we realize what we're doing. We're just asking what number, or a number raised to what power gives me another number. So I know how to do 2 to the third power. 2 to the third power is 8, right? It's just 2 times 2 times 2. What's harder for us sometimes is to work that idea backwards and to say, okay, I got 2 raised to some number, gives me 8. What's that number? And logarithm is the tool that gets me that answer. Okay? So let's go to examples. We're going to do as much of these as we can together in class. And then whatever we get done together in class, that comes off of your homework that's due on Friday. Deal? Do we like that idea? All right. So, now look at number 3. I've replaced the term what power with what? With log, right, Olivia? So 6, and this is where I get the term log roll, really, right? Call it the log roll. Get it? Log roll. 6 to what power gets me 36? 6 to what power? Not 6 times what? 6 to what power? Yeah, 6 to the second power. 2 to what power gets me 32? 5. Does anybody notice something strange about these questions? They're the exact same questions as they were on the front page. Yes, that's all it means. That's all it means. 10 to what power gets me 1,000? 3. 42 to what power gets me 1? 0, because x to the 0 always equals 1. 100 to what power gets me 0.01? -1. Now, it occurs to me, I want to do this one. I want to do this next one on the calculator so I can show you how to use the calculator. Because what's going to happen here is you're going to get numbers that aren't, if I ask you, what is the log base 2 of 3.8? I can't reason that in my head, right? So I need to know how to use a calculator. So 2 to what power gets me 8? I use log for that. How do I use log on a calculator? Let's turn on our calculator. Can everybody see my calculator up here? All right, so then I take the log, it's just going to say log. I hit log, and then it puts up log with a parenthesis. And I'm going to do, well, here's what I'm going to do right now. This is going to be log on the calculator is always base 10. Okay? So I'm going to say, what power of 10 gets me 12 and a half? I'm going to find this. So 10 to what power gets me 12 and a half? So I'm going to do log of 12.5. I'm going to end my parenthesis, and I'm going to hit enter. And then I realize that 10 to the 1.0969100013 power gets me 12. Let's test that. Let's go 10 to the answer. Enter. 12.5. Do we see how that works? Yes, sir.
I don't want to do base 10.
We're going to get to that, but not today.
All right.
All right?
All right.
Beautiful question. I love that question. So, back to, I probably busted that out too early, but it is what it is. Log base 2 of what? Or I'm sorry, log base 2 of 1/4. What am I asking? 2 to what power gets me 1/4? -2. -2. I'm just doing exponents backwards, right, ladies and gentlemen? All right. Oh, we got through all those in the time we had in class. I am going to assign you number 10, A through M. Do all of them. And I'll be due on Friday. This is going to give you some experience and some exercise practices in logarithms. Okay?